Hey guys, Nate's dad here. I wanted to cover three things in this video. Basically, I wanted to update you on where we stand in general with converting the high torque mini mill to CNC operation. This is a follow-on video from a couple of others that are on the same Zim Knives YouTube channel. So I'd probably recommend viewing those first and then coming to this one. Secondly, I wanted to talk about some hints and tips that we found along the way in following the instructions that we chose to follow. And thirdly, I may or may not fit this in this video. I may do another short one afterwards on limit switches, what we did in terms of mechanical and electrical design for limit switches. So first of all, we followed these instructions as we've noted in some of the other videos. A great set of instructions as we've noted by Nick Raymond, Make Projects. It's got some great, we printed it out, but it's available online. It's got some great pictures and really descriptive words, and generally it was flawless in helping us do the conversion of the mill. There were three things that I think are worth noting with respect to following those instructions. The first one is relates to the Z-axis. Up here you can see that there was an existing sort of the nose, if you imagine two eyes and a nose, that screw at the bottom. When we had the Z-axis aligned very well, we noticed that that third hole didn't really align all that well, so we drilled that one out a little bit. Wasn't too worried about that because we had the two cap screws at the top that bolted all the way through the steel to hold that axis in place. Secondly, down here, this block, which actually connects the ball screw to the axis itself, to the meat of the axis itself, is bolted in two ways. One from the outside into a couple of existing holes that used to hold the manual Z-axis mechanism. But there's also a large bolt that goes from the inside out. That one was particularly tough to figure out how to get in. We basically had to lift the mill almost all the way off of its dovetail in order to put that large, I believe 17 millimeter cap screw in. Two-person operation I would recommend, but it worked out in the end. Thirdly, and this is probably the most major, with respect to the X-axis, we followed the instructions and put the X and Y axis together, and they ran pretty well. But what we noticed with the X-axis was a little bit of once per revolution knocking noise. Now I've heard that and seen that on a number of postings on the web with varying solutions. We tried all of the things that related to alignment of the axis, and those really didn't help completely. There was always some portion of the travel where that noise happened. So ultimately we ended up disassembling and inspecting and noticed that there was some interference indicated by some scratching and scraping of the paint on the underside of the carriage itself. There's a channel that runs the length of the X-axis where the ball screw rides, and we noticed some of the paint under there was scratched. Our remedy was actually to take this to a local machine shop and have them take 20 or 30 thousandths off of the underside of that channel, and that solved the problem completely. So I think we have had a good solution to that. So three things: that one screw up there, getting this large 17 millimeter cap screw from the inside out, and machining off a little bit, providing a little bit of relief in terms of the spacing between the ball screw and the underside of the carriage. After that, we have really good operation, I think, of all three axes. I'll move them just to demonstrate. That's the Y-axis travel, kind of peppy and very smooth. Same with X, and Z-axis travels very nicely up and down as well. So we got good operation on all three axes, and I'm going to call this video ended here and start up a new one for the limit switches.